Hi, everybody. I hope you can hear me. Welcome to this live. Perhaps you could just say something in the chat that makes it clear that you can see me. No, nobody's saying anything yet. Perhaps you haven't got me yet. Oh, good. Brilliant. Okay, so what I'm going to do is I'm going to share my screen and share the paper, and then I'll wait a couple of minutes to give everyone a chance to join the live and everyone a chance to be organized. Okay, so I'm hoping that you have downloaded the paper. The link is in the chat. So if you haven't downloaded the paper, perhaps download it now. At the very least, maybe have it on a different screen so that you can be alongside us. All right, so I'm kind of hoping that you have got on your screen now the hi everyone message. Okay, and that's where the paper will appear when we work on it together. If you've already done the paper, then you're doing well. Okay, it'll just be a question of keeping half an eye on me as I do it, and then you can check your answers against mine. And of course, if you've got any questions, you can ask about it. Okay. Now, the paper isn't a complete collection of every topic which hasn't yet come up, because otherwise we'll be here far too long. Okay. If you want the link to the paper, I think if you go right up to the top of the chat, you'll see. Oh, I can't see it there now. Okay, I will put the link. Okay, I'm doing it. I'm going to find the link now. Okay. Right. Okay. Right, here comes the link. Okay, I've just put it in the chat. Okay. So there's the link. Click on the link, get hold of the paper that we're going to work through today. All right. Now, not every question that could come up, not every topic that could come up is on this practice paper. And I've tried to take a kind of middle ground. There didn't seem any point in us taking an hour over doing grade 9 questions only, because that would leave some of us feeling like we weren't going to do very well tomorrow. And it would leave others feeling like, you know what I mean. So I've tried to take a middle ground on this paper, but it will help you to remember a whole load of different topics which haven't yet come up on paper 1H. So we're going to start in 3 minutes. I'll put the link again in the chat. Okay. And what I would do is, if you haven't got time to print the paper, then I would just have it on a different screen so that you can be working. You can work ahead of me if you want to. All right. Okay, so we'll start in a couple of minutes. Bearings could come up, yeah, although it's not something that I've included on this paper. Okay. But I think I have included about 10 or so topics, all of which haven't come up. Okay. Some of you are asking about what the grade boundaries might be, and once we've seen the second paper, then I'll do a grade boundary analysis and I'll put a film on the channel. I can't leak tomorrow's paper, I'm afraid. I'm just not able to. I haven't got it. Okay. There is a cumulative frequency question on this paper, and yes, it's quite straightforward if you know what you're doing. Okay. So they do add the marks for both papers, yes. So you end up with a mark out of 200, and that is what they base your grade upon. Okay. Is this all the topics or most of the topics? I think it's most of the topics that I'm predicting come up. But of course, there are other topics which could well come up, like proof, for instance. Somebody said on the channel, look, you haven't included proof in your predictions. No, because I can include every topic. Happy birthday, Poppy. Well, just 6 won't exceed 84. I don't know. Last year, in the summer, wasn't the grade boundary a bit higher than 84 for a 6? I can't remember what it was. You can still get a 9, yeah, I would think so. Yeah, no, I know I've forgotten proof. I've just mentioned that. That's one of those topics which hasn't come up yet, and it could well come up. Okay, but I couldn't include every topic on the paper, not least as I've only got an hour. Okay, right. It is, what is the time? It's 4:35 here in the UK. So I'm going to begin. Now, clearly I can't control what you write in the chat and what you don't write in the chat, but I would imagine it would be useful if you tried to restrict the chat to conversations about the question we're doing, because then if anybody asks a question, then at least I can see, at least I'll see their question. Okay, so I'm just going to work my way through now from question 1. Okay, and question 1 is a straightforward probability question. So here I go. We've got a 5-base spinner. By the way, when you're reading the questions in the exam, I would underline the bits. Read them carefully. You've got 2 hours. You're not going to run out of time. Okay. Here's a spinner, can land on one of 5 colors. The table below shows the probability the spinner will land on red, on blue, or on green. The probability that the spinner will land on orange is 3 times the probability the spinner will land on pink. So this number has to be 3 times the probability of it landing on pink. Work out the probability the spinner will land on orange. Well, so far, I have got those 3 probabilities. And those 3 probabilities add up to 0.4. Now I know that all of the 5 probabilities must add up to 1. So I know that orange and pink together must add up to 0.6. Now it would be tempting to think they're 0.3 each, but they're not, because the probability that the spinner will land on orange is 3 times the probability the spinner will land on pink. So I'm going to need to split this 0.6 into 4 parts, and 1/4 of it will be for pink, 0.15, and 3/4, 0.45, will be for orange. Moving on, if you spin the spinner 150 times, work out and estimate the number of times it lands on blue. Well, it lands on blue 0.12 of the time, 12% of the time, and I'm spinning it 150 times. So 12% of 150 gives an answer of 18, and I'm moving on because nobody has put a question in the chat. Okay. Question 2. Right, this is a harder probability question, and then question 3 is harder still. Okay. Right. So there are 16 sweets in a bowl. 4 are blackcurrant, 5 are lemon, and 7 are orange. And look, I really would read the question as if you're a primary school teacher when you're doing your paper. Anna, Ravi, and Sam each take at random 1 sweet from the bowl. Work out the probability that 5 lemon sweets are still in the bowl. Well, we start off with 5 lemon sweets. And so what we really want to know is what the probability is that the first person doesn't take lemon. First person, not lemon. And then we want the second person, not lemon. And the third person, not lemon. Because at the end of the day, we don't care what they take out as long as it's not lemon. Now, the probability of the first person taking out not lemon is 11 out of 16. Because there are 11 sweets out of the 16, which aren't 11. Now, once they've taken the sweet, there are 15 sweets left in the box, and 10 of them not lemon. And once that second person's taken the sweet, there are 14 sweets in the box, and 9 of them are not lemon. So the probability of the first person taking not lemon, and the second person taking not lemon, and the third person taking not lemon is the product of those fractions, 33 out of 112. Okay, right. I don't know whether you're saying I'm going too fast or going too slowly. Okay. All right, so do you want me to just run through the ideas behind this question again? Oh, I'm going too fast. Okay, sorry about that. I thought you'd already done the paper. Okay, I've got the message about slowing down. So I'm just going to pause for a moment. Here's the first person choosing not lemon. Here's the second person choosing not lemon. And here's the third person choosing not lemon. So I've multiplied all three probabilities together. So I get the probability of the first person choosing not lemon and the second person and the third person. Okay. All right. Now, I'm going to move on in a second or two to question 3. If you're thinking I'm going too slow, then go on to question 3 now, right? Don't wait for me. Okay. And I'll just pause a moment. All right. When you finish the question, please go through it again. Okay. I think I've talked through question 2 twice now. So where's the paper? I put the link in the chat. If you make your way up the chat, you'll see a link to the... Okay. Right. A bowl contains n pieces of fruit. Right. While you read that question, I'll copy the link into the chat one more time. Okay. There's the question. Right. Meanwhile, I'll copy the link into the chat for the paper. There's the link. Okay. Right. This is a tough probability question, this one. It is a question 20. Okay. The live only started at 6 minutes ago, so you're doing okay. No, you won't lose marks if you draw the graph with a pen. Okay, good. I hope you found the 50 questions useful. Now, question 3. A bowl contains n pieces of fruit. Of these, 4 are oranges and the rest are apples. Right, stop. Oranges, 4. Apples, n minus 4, since there are 4 pieces of fruit altogether. Okay. 2 pieces of fruit are going to be taken at random from the bowl. Okay, I understand that. The probability that the bowl will then contain n minus 6 apples is a third. Right. Well, at the start, the bowl contains n minus 4 apples. And now I'm being told that after taking 2 pieces of fruit, the probability that the bowl will contain n minus 6 apples is a third. Well, if the probability of the bowl containing n minus 6 apples is a third, well, that must be the probability of the first one being an apple and the second one being an apple. Because that's the only way you're going to end up with n minus 6 apples, because you started with n minus 4 apples. So both the pieces of fruit taken out must be apples, because then you end up with n minus 6. So the first thing to understand is that we need to work out the probability of the first one being an apple multiplied by the probability of the second one being an apple, and that is going to equal a third. So what's the probability of the first one being an apple? Well, how many apples are there in the bowl? N minus 4. Out of how many apples altogether? N. So the probability of the first one being an apple is n minus 4 over n, multiplied by. What's the probability of the second one being an apple? Well, there used to be n pieces of fruit in the bowl, but I've taken away 1. So now there are only n minus 1 pieces of fruit in the bowl. And it used to be that n minus 4 of them were apples, but I've taken out an apple, so now it's n minus 5 of them are apples. So the probability of the second one being an apple is n minus 5 over n minus 1, and that is what equals a third. And so this is a tricky question, because you've got to get that equation, and now you have to solve it. Okay? Now, when it comes to solving this equation, there are lots of different ways that you could do it. All right. I'm going to multiply this as n minus 4 times n minus 5, top by top, and multiply bottom by bottom, equals 1/3. And now I'm going to cross multiply. So I'm going to end up with 3 lots of n minus 4 times n minus 5 equals 1 times n minus n lots of n minus 1. Now from now on, it's just algebra, okay? So just don't make a mistake. 3 lots of, I'm going to multiply out these two brackets, expand those two brackets. It's going to be n squared. I'm going to get minus 4n and minus 5n, so that's minus 5n plus 20. Minus 4 times minus 5 is plus 20, equals n squared minus n. Now, left-hand side, multiply out that bracket. 3n squared minus 9n plus 20. Sorry, that's rubbish. I'll try that again. 3n squared minus 27n plus 60 equals n squared minus n. So what I've got here is a quadratic equation. Set it equal to 0, and then try and factorize it. Minus n squared for both sides, 2n squared, plus an n to both sides, minus 26n, plus 60 equals 0. So I'm going to factorize this equation. I'm going to solve this equation to find what n is. So far, I've got this. 2n squared minus 26n plus 60 equals 0. You could solve that by using the formula, or you could solve it by factorizing it. I'm going to factorize it. I'm going to take out the 2 first. To be honest, if I was doing this in the exam, I'd probably have used the formula. But the thing is, I've worked out in advance. Okay, so I know that that will factorize to n minus 10 lots of n minus 3 equals 0. So my solutions are n equals 10 or 3. Okay, you could have used the formula, of course, so don't stress about my factorizing. Now, that's 2 values for n. Let's go back to the question. N is the number of pieces of fruit in the bowl, right? Well, it couldn't have started with 3 pieces of fruit in the bowl, because then you'd have had a negative number of apples at the start. So the only feasible answer is that n equals 10. And that is 6 marks, so that's half a grade. Okay? Right, I'm moving on. If you're somebody who hates probability, you'll be pleased to hear that's the last probability question. Okay? I'll leave it there for a second, and then we'll move on. I'm just having a quick look at the chat. Okay, now they said the oranges was n minus 4, so therefore it can't be a negative number of oranges. Right. Now, by the way, that's a question 20. Some of you, if you're aiming for a grade 6, just get all the part marks you can on the harder questions. Question 4 is coming up. I'm going to pause for a moment in case you haven't got the question paper. Right. Now, here we're adding fractions. Now, you know when you add fractions, you change each fraction so the denominators are the same. How do I decide what to have as my common denominator? Well, I'm just going to multiply these 2 together. So I'm going to write this as a common denominator of 24x. Now I know that I could use a lower common denominator. I know that it could be 12x, but I'm going to do 24x, because then I can just go 3 times the 6x to get 18x, and 4 times the 5 minus x to get my 2 numerators. Now I appreciate that's not the lowest common denominator, but I like doing it like this, because then I don't have to think so much. So I've got that, which equals 18x plus 20 minus 4x all over 24, which equals 14x plus 20. Oh, I've missed out the x here, 24x. 14x plus 20 over 24x. And now I can simplify that fraction by dividing the bottom and the top by 2. Gives me 7x plus 10 over 12x. Okay, and if I'd actually used the lowest common denominator, then I would have got 7x plus 10 over 12x from the start. And it is 24x, thank you, well spotted. But I got there in the end. Okay, all right. Anybody want to ask anything about question 4? If you're happy with question 4, move on to question 5. Yes, they do repeat topics in paper 1 and paper 2, especially percentages and especially probability, I'm afraid. The link is further up in the chat. Okay, right, question 5 coming up. I've got to keep moving, I'm afraid, because I've got to end this at about 5:30 my time. Right, I'm going to make x the subject of this expression here. Okay. Okay, I can try and go a bit slower, but and I'll do my best. But remember, you can always rewind the live, and as soon as the live is finished, the whole recording will appear on the channel as well. But yeah, I'll do my best. Okay. Right, I've got to make x the subject of this. So I have got y equals the cube root of 6 plus 5x over x plus 4. The first thing I'm going to do is cube both sides to get rid of that cube root. So I'm going to have y cubed equals 6 plus 5x over x plus 4. All I've done so far is cube both sides. Okay. All right. Now, I'm now going to multiply by what I've got on the bottom to get rid of that. So I'm going to multiply both sides by x plus 4. Y cubed times x plus 4 on the left and 6 plus 5x on the right. And now I'm going to multiply out the bracket on the left. Okay. Y cubed times x plus 4y cubed equals 6 plus 5x. Okay. Now, you often have something like this in a question. And you've got to make x the subject, and x appears twice. In this case, x is here and x is here. So what I'm going to do is I'm going to get all the x's on one side and all the other rubbish on the other. Okay? So I'm going to subtract this 5x from both sides. And I'm going to subtract 4y cubed from both sides. So if I subtract 5x from both sides, then on the left-hand side, I get y cubed x minus 5x. And I've got rid of the plus 4y cubes because I'm minusing that from both sides. So that makes its way to the right-hand side. Okay. So can we keep the comments helpful, please? Because it does make life easier for everyone. Now, I've got everything on the x with an x in it on the left and everything, all the other rubbish on the right. Now, you've got to fad this now. Factorize and divide. So I'm going to factorize the left-hand side, which means that I take out the x. So where there were 2 x's, there is now just 1. And factorize and divide, I'm now going to divide both sides by that. So I'm left with x on the left and 6 minus 4y cubed over y cubed minus 5 on the right. And I have made x the subject. I'm going to pause for a minute. Okay. And if you're fine with that question, move on to question 6. Okay. Right, question 6 is a question 26. So it's going to be tricky, okay? And if you look at question 6 and you think, actually, I wouldn't actually try that question, then of course you can watch me do it. Or alternatively, you can just carry on through question 7, question 8, and question 9 and question pick. Okay? Right. Okay, I'm going to move on now to question 6. Here it is to tell you that it wasn't a great looking question. All right. So, if you get a question like this, then what you need to do is you need to think, well, I'm bound to have to factorize these expressions here. So just crack on with it and factorize them, okay? But you can be a bit strategic about this because you probably already recognize how to factorize x squared minus 25. So you know you're going to have something over 2x minus 1 times something over x plus 5 lots of x minus 5, and then you've got plus 29 minus 4x. Now, I suppose this is a bit cunning, really, but you know how you've got these here? Well, that seems likely that one of those will cancel with something here. So I'm kind of thinking that one of the factors top left is going to be x plus 5 or x minus 5. So I know it's going to start with an x and have a 5 there. And that means that this will need to be a 4x to give me my 4x squared. And this will have to be a 3 to get my 15. And then it's just a question of putting your minus and plus sign in, so you end up with minus 17x. And so that's going to mean that you are going to want to have 4x plus 3 here. Have I got that right? 4x plus 3, that's right, and x minus 5, because then if you were to multiply out those brackets on the top, you end up with minus 17x. So I've factorized the top of the left. Right, factorizing the top of the right. Well, again, you can be slightly strategic. It's pretty likely that this is going to be a factor. So start off by thinking, okay, let's try it 2x minus 1. And if it is 2x minus 1, then the other one must be x minus 3, and then you can check to see if that gives you the correct number of x's, and it does. So that's my factorizing trick, but think about it quite strategically. And now you can cancel. I can cancel 2x minus 1 and 2x minus 1, x minus 5 and x minus 5. So I get 4x plus 3 multiplied by x minus 3 all over x plus 5 plus 29 minus 4x. So I'm just pausing a minute. Nobody seems to be talking about this question in the chat, so I'm going to carry on. Right. If I was doing this question, I'd want to write this fraction over x plus 5, which would mean that I'd multiply the top by x plus 5. So what I'd actually end up with is 4x plus 3, lots of x minus 3, plus 29 minus 4x, lots of x plus 5, all over x plus 5. Okay. Right. Now I'm going to expand the brackets on the left. I'm expanding those brackets now. 4x squared. The x's will be minus 12x plus 3x minus 9x minus 9 plus 29 times that second bracket. 29x plus 145, that's 29 times 5. Now minus 4x times the second bracket, minus 4x squared minus 20x, all over x plus 5. Simplify the top. Well, I've got 4x squared and minus 4x squared. So they forget about those, right? I've got minus 9x plus 29x gives me plus 20x and minus 20x, so I can forget about those. So the top boils down to minus 9 plus 145, 136 over x plus 5. And that is quite a difficult 4 marks, but it was, after all, the question 26, so it was probably the last question on that. Okay, I'm moving on. to question 7. Right. Everyone can get 1 mark here, as long as you remember that anything to the power of 0 equals 1. Right. 3 to the power of minus 14 times 3 to the power of 8. Well, wait a minute. Add the indices, don't you, when you multiply? So that's 3 to the power of minus 6. Sorry, it's not 8 to the power of anything. That's 3 to the power of minus 6. So I know that m must be minus 6, because that's 3 to the power of m. So m must be minus 6. Okay. Question 8. Right, when you get a question like this, the left-hand side is in base 2. It's 2 to the power of something. So change the right-hand side to 2 to the power of something as well. And 32 is 2 to the power of 5. So you've got 2 to the power of minus 4x equals 2 to the power of 5. So minus 4x must equal 5. So x must be 5 divided by minus 4, which is minus 1 1/4. Okay, so that is the end of question 7. Just going to pause and look at the chat. Nobody seems to be asking me about question 7. Okay, moving on to question 8. Here's another question, and I've got some different bases at work here. I've got base 2, base 4, and base 4. So I'm going to change them all to base 2. The answer to question 5, here we go. Well, you can make your own way back in the film, can't you, I think? But since I've started, the answer to question 5 is that. Okay, right, but I'm going to need you to wind your own way back from now on, I think. Right. Okay, we're on question 9. So we need to put everything into base 2. Okay? Now, 2 to the power of 7, that's already in base 2. 4 to the power of 5, that's not in base 2. Well, 4 is 2 squared, isn't it? So that's 2 squared to the power of 5. So that's 2 to the power of 10. Remember, you multiply those. So 4 to the power of 5 is 2 to the power of 10. So I've got 2 to the power of 7 times 2 to the power of 10. And apparently that equals 4 to the power of x. Well, let's put 4 to the power of x in base 2. 4, 2 squared. So what you've got is 2 squared to the power of x. And remember, you multiply those, so that equals 2 to the power of 2x. So what we've got is we've got 2 to the power of 7 times 2 to the power of 10 is 2 to the power of 2x. So that means that, oh, wait a minute, 2 to the power of 7 times 2 to the power of 10, that's 2 to the power of 17, because you add the indices. So 2 to the power of 17 equals 2 to the power of 2x. So 2x is 17, so x is 8.5. Okay. Oh yes, I could have, yeah, perhaps that's a better idea. I could just have taken this 2 and changed it into base 4. Yes, you could have done that if you wanted to. Okay. All right. Now, part B here. I've got something in the bracket to the power of 2/3. Okay, something in the bracket to the power of 2/3. So, if you're bringing something to the power of 2/3, then you can think about cube rooting it and then squaring it. So that's what I'm going to do. I'm going to cube root it and then square it. Now, the cube root of 125, well, you could do that on your calculator, but it's 5, because 5 times 5 times 5 is 125. The cube root of p to the 6 is p squared, because p squared times p squared times p squared is p to the 6. And the cube root of y to the power of 24 is y to the power of 8, 24 divided by 3, because y to the 8 times y to the 8 times y to the 8 is y to the power of 24. So that's it cube rooted. So all I've got to do now is square it. So that's going to be 5p squared y to the 8 times 5p squared y to the 8. 5 5s are 25. P squared times p squared is p to the 4. y to the 8 times y to the 8 is y to the 16. Okay? And that is 4 marks there on what was a question 12 in November 22. Okay? I'll have a quick look at the chat. I don't think anybody is asking about this question. Can we leave question 8 as a fraction? Yeah, of course you can. -5/4 would be absolutely fine. Okay. All right. Anything else? Okay, we're moving on. Okay, polygons hasn't yet come up. So I've got a relatively easy question on polygons and then a more difficult question on polygons. Right, this diagram shows a pentagon. Work out the value of x. Well, what you need to be doing here is you need to be thinking, what do all the interior angles of this shape add up to? Now, a pentagon has got 5 sides, so the total of the interior angles is 3 times 180. The number of sides minus 2 multiplied by 180. So the total of all the interior angles, I think that's 540. And so x will be 540, subtract the angles that you already know. Okay, work out the total number of degrees in the whole shape, take away the ones you know, and you work out that x is 129, I got. Okay. Any problems with that? Why did I times by 3? Right. First of all, in the nicest possible way, you probably need to know that to find the total number of degrees in a polygon, you get the number of sides minus 2, and that's how I got 3 this time. Why is it 3? It's because if you split a 5-sided shape up, you get 3 triangles. Okay? Right. Now we're about to do something very similar here on question 11. I'll pause for a minute, but in a moment, we're going to work out the total number of degrees in this hexagon. So we're going to use the same method. Okay, I'm just going to look at the chat while you guys have a look at that question. How was this paper predicted? Well, what I did was I looked at all the topics that came up in paper 1, and then I decided what topics were likely to come up in paper 2. So it's not really a predicted paper. It's more a number of questions on the topics that are likely to come up tomorrow. Okay. There might be kinematics, but we've already had differentiation. So I don't know. If I was guessing, I'd guess we wouldn't have kinematics. I don't know about the grey boundaries. When I see the second paper, I'll do it. All right. Question 11. Now, we've got here a hexagon. So we could work out the total number of degrees in the hexagon. And if we do that, then we can work out this missing angle. If you work out that missing angle, then you will know the size of this green angle, which is the interior angle of the polygon, which we are trying to find the side length, the number of sides of. Okay? So we're going to start off by finding the total number of degrees in this hexagon here. Now it's a hexagon, it's got 6 sides, so the total number of degrees is 4 times 180. And so the 4 times 180, what is that? 720, I think. So the size of the blue angle will be 720, subtract the angles that we know. Okay, so that blue angle is 225. Okay, so the green angle is 360 minus that. So the green angle is 135. So what we've got here is we've got a polygon. Here it is. This is the polygon we're talking about. There, there, there. And of course it carries on, right? I just don't know how many sides it's got, right? So we've got a polygon with an interior angle of 35, a regular polygon with an interior angle of 35. sorry, 135. So we know its exterior angle must be 45. So we know the number of sides is 360 divided by 45. The number of sides is 8. So it's an octagon, isn't it? And it says calculate the value of n. So n is 8. All right. Okay. I think you'll find the teachers don't get the paper until after you've sat the exam. Okay. All right. So that's question 11. Can I move on to question 12? 8, yes. Okay. I haven't seen the paper. No, of course I haven't. Now, I'm not going to redo it, but you can go backwards on the line. Okay. All right. Okay. Can I post the mark scheme with these questions? I'm not sure. I'll have a look. I'll have a go. But you've got me working through them on the replay of the live anyway. Question 12, circle theorems. Now, circle theorems haven't come up yet. So we need to make sure we do a couple of circle theorem questions. Okay. So I'm about to do question 12. Right. So in question 12, you can read all the information, and when you're doing your paper, you really should read the information and tick it off and make sure those angles are marked on the diagram. Find the size of angle BDC. BDC, this angle. So that angle is the target angle that we are trying to find. Okay? Remember, you've got loads of time in the paper, so you really have got time to read the question carefully. Right, that's the target angle. Okay. Well, what can I see at the minute? Well, you see the chord CD. That means that this angle here and this angle here are equal because they're angles in the same segment. So that angle at A is 28. Okay. All right. Now, what else can I see? Well, I've got a diameter here, which means that this angle is 90, because this, watch, is a triangle in a semicircle. So that angle is 90. Now I think I'm getting somewhere, because if I were to look at this triangle here, I know that two of the angles are 28 and 90. So I can work out the whole of that angle. 180 minus 90 minus 28. The whole of that angle is 62. And look at this. I know this bit's 32. So I know that my target angle is 62 minus 32, which is 30. Now, if you get a question like this, and you don't know what to do, then just find any angles you can and hope it leads you to either some part marks or to all the marks, because it leads you to the angle you want. Now, some people have asked questions about simultaneous equations. Yes, I am absolutely sure simultaneous equations will be in tomorrow's paper, but I haven't included them here because there were questions on simultaneous equations during Tuesday's live. So you can go back to look at simultaneous equations. Although perhaps simultaneous equations wasn't paper 1, I don't know, I didn't sit it. And while I've seen the paper, I haven't done all the questions. Okay. Is angle BCD also 32? BCD, I don't know. BCD is more than 90, isn't it? But I think you might mean BCA, but I don't know at the moment. I can't see it. Yes, it is, because it's angles in the same segment. Very nice. So that is 32 there, yes. Okay, I'm moving on to question 13. I think simultaneous equations is hidden in one of the harder questions, but I haven't done the harder questions. I only had a quick flip through them. But you must expect to see simultaneous equations tomorrow. Okay, transformations of curves here. I'll tell you what, we'll come back to question 13. Let's stick with circle theorems, and let's do question 14. This is another circle theorems question. Okay? Okay. Can you focus on end questions? Well, I'll get there, is the answer. Right, I've got 15 more minutes, then I've got to go. Okay. In this question, you've got to find the sine of angle RQP. RQP is this angle here. That angle. Well, that's an angle in a semicircle, so it's 90. And then it says give a reason. So you say angles in a semicircle is 90. Find the size of angle PSQ. PSQ is this angle here, and it is 22 because it's the same as that one, because angles in the same segment are equal. So that was quite easy, that question, I hope. Okay, moving down to question 15. I'll pause for a minute, have a go at question 15. Yeah, I don't know where the simultaneous equations was, but it might have been in that geometry question, Miriam. I don't know. Okay, but you should expect simultaneous equations to come up in your paper. Okay. All right. What was the reason for 22 degrees? Let's have a quick look. Oh, well, it's angles in the same segment. Look, this chord here, right? 22, 22. Okay, angles in the same segment are equal. Right, we're on question 15 now. Now, one of the things that's really helpful to spot when you look at a circle theorems question is if you've got a triangle from the middle, like this one, then that line and that line are of equal lengths because they're both radiuses. So what you've got there is an isosceles triangle. And it's very useful to spot that that is an isosceles triangle. And in this case, that means that that angle there is 52. Now, once you've done that, in this question, you can find this angle because it's the third angle of the triangle. 180 minus 52 minus 52 gives you 76, I think. So that angle is 76. Now, this angle, the 76, is an angle at the center. And this angle is an angle at the edge. So it's half of the 76, isn't it? Because the angle at the edge is half the angle at the center. And so that is that question done. Okay. Right. Everyone's chatting about something else in the chat, so I'm moving on. Question 16. Why did I get 80? Where did I get 80? You can't see 80 in. So presumably you're talking about something different in the chat. Aha, question 16, right. Stop chatting, look at this. This is a hard question on intersecting chord theorem. And I have a system for you on intersecting chord theorem questions. First of all, make sure that one of your chords is called AB and make sure the other one is called CD. And if they're not, rename them. Make sure your point of intersection is called P. And if it's not, rename it. And then do this. A, B, C, D equals in the middle. P, 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 P times. Okay, I'm going to do that again. A, B, C, D, everyone knows their alphabet, equals in the middle. The point of intersection, the point of intersection, the point of intersection, times and times. And that just does the intersecting chord theorem for you. And now we're just going to fill in the numbers. AP, this says here. What is the length of AP? The length of AP is 30. BP is 14. So on the left, I've got 30 times 14. On the right, CP is 12, isn't it? Times, now DP. It's asked me to find DC in this question, so I'm going to call DC X. So DP is X plus 12. And now, this is a relatively straightforward equation. 420 on the left equals 12x plus 144, minus 144 from both sides. 12x equals 276. Divide both sides by 12, x equals 23. Okay, but this is very useful. Right. I'm going to move on, if you're happy, to question 17. This is the last question on the paper. It's not the longest paper in the world, but then I will have 5 or 10 minutes if you want me to find a question on a different topic or go back over any of these questions again. Okay. Right, cumulative frequency. Now, I think cumulative frequency is quite straightforward, but it hasn't come up yet. So the reason I've included it is because I thought if I remind you all about the topic and then it comes up, you'll get the marks. Okay, so the table gives information about 80 people running a race. Here we go. 15 fit in there, 16 in there, 21 in there, and so on and so forth. The cumulative frequency, well, from 50 to 60, it's 15 people. What about from 50 to 70? Well, that's going to be these ones and those ones, so it's 31. What about from 50 to 80? Well, that's these, and these. So it's 31 plus another 21 gives me 52. Well, add another 14 here gives me 66, I think, is it? And then 74, and then 80. So there is my cumulative frequency table. Okay. Right. Now I've got to fill in the cumulative frequency graph. So I'm wondering if I can move this. Let's have a look. Okay. Right. I'm going to move my cumulative frequency graph next to my cumulative frequency table. Here we go. Okay. So when I do my cumulative frequency graph, I use the endpoints. I've got 15 people who are less than 60. So there's my point. I've got 31 people who are less than 70. I've got 52 who are less than 80. Just be careful of your scales. In this case, it's quite an easy scale. I've got 66 who are less than 90. I've got 74 that are less than 100, and 80 that are less than 110. So here, nice, smooth curve. I feel like I've got something wrong because it doesn't look terribly extreme, but I think I've got everything right. I don't think I plotted something wrong. Okay, there is my cumulative frequency curve. Okay. Use your graph to find an estimate for the median taken. Right, the median's the halfway one. Be careful. Do I do halfway on this axis, or do I do halfway on my x-axis? Well, the answer is that you think, wait a minute, how many people were there altogether? 80. So I do the 40th person. So I'm going to do halfway on the cumulative frequency axis. And what I'm going to do is I'm going to use my ruler, and I'm going to draw till I hit the cumulative frequency graph, and then I'm going to draw down here and read off the median, the time taken by the 40th person. And I get 75 on this drawing here. Use your graph to estimate the interquartile range. Well, 40 is the halfway, so I need 20 for the first quartile and 60 for the second quartile. So I need to read off the time taken by the 20th person, which I make 60, is that 63? I make 63. Okay, so my lower quartile is 63, and the upper quartile is the time taken by the 60th person. Right, here we go, 60th person. That's not very accurate. Try and draw that better. There we go. And down we go. So I make that 85, I think. So it's going to be 85 minus 63. So the interquartile range is 22, according to my there. Okay. Right. That is the end of the questions which I put to one side to go through with you. Although, wait a minute, did we miss one out? Let's have a look. Oh, we missed out the transformations. Okay, we missed out the transformations. I'll do that. Here we go. Okay, I'm on question 13 now. Okay? All right. So, question 13. Now, we've got a curve y equals f of x. Now, we don't know much about the curve, but we know there's only one turning point, and it's at 6, 5. So we can imagine, just for the sake of argument, that the curve looks something like this. 6, 5. If in doubt, draw it out, is one of my annoying phrases. There you go. There's the curve. It's got a minimum point at 6, 5. Okay? That's even worse than the first attempt. Write down the coordinates of the turning point if it has the equation y equals f of x minus 4. Now, this change is in the bracket, so it's going to go horizontally, and it's going to go the wrong way. You might expect it to go backwards 4, because you've got a minus 4, but it's going to go the wrong way. It's going to move that way 4. So it's not going to be 6 along anymore. It's going to be 10 along. So the answer to this question is 10, 5. Let's just do a couple of these. So let's imagine that the question was, what about the turning point if you had y equals f of x? And look, I'll put the change outside, f of x minus 4 like that. What would it be there? In this case, the change is outside the bracket, so it's going to be a vertical change, and it's going to go the way you'd expect. So in this case, the minimum point would go down by 4. So it would still be 6 along, but it wouldn't be 5 high anymore. It would now be 1 high. Okay, but that wasn't the question we were doing, so don't get confused by that. Right. Okay. Now, what about y equals f of 3x? Well, this time the change is in the bracket. So again, here the change is going to happen horizontally, but it's going to happen the wrong way. So the x coordinates are going to be divided by 3, not multiplied by 3. So it's not going to be 6, 5 anymore. It's now going to be 2, 5, 2 along and 5 up. To be honest, I think the easiest way to do these questions is just to remember the rules, which with any luck, you've covered at school. Yes, 6 divided by 3, that's right. 2, 5. Okay. 2, 5, I'm afraid, because 6 divided by 3 is 2, not 3. Okay, right. That concludes the practice paper there. What suggestions do I have for you? Well, a couple of suggestions. First of all, if there are other topics you want to do, then you'll find films on the channel. And if you've watched the predictions film, then you'll have a link to the relevant playlists. If you want to practice simultaneous equations, then make your way to the live from a couple of nights ago, because there were 2 simultaneous equations questions there. One was linear like this. I can't remember what it was, but who cares? And the other one was one where one of the equations was quadratic. And I wouldn't be surprised if you had both of those questions there. Okay, now I'm sorry, I know you want to do bearings. 3D trig, there's a playlist for 3D trig on the channel, and there are loads of IGCSE questions talked through. Okay, I am reading the chat, and I can see that everybody wants to do bearings and all sorts of things, but I just haven't got time now. But I hope that you have found what we've done useful. And if you want to replay this chat, this live, then of course you can. But if you would like to do any other topics, you will find playlists on the channel. But look, yes, I know you want to do bearings, and we're not going to do bearings. So good luck tomorrow, get a good night's sleep, and I will put a film on the channel so you can tell me how it went for you tomorrow. I would love to hear. And then in a couple of days' time, I will put a grade boundary prediction film on the channel. Okay, so well done. Good luck to you. And I hope that your exams go really well for you tomorrow. Right, I'm going to end this live now. Okay, so I will wish you all the best for tomorrow. Okay, cheerio.